Okay, today we're going to talk about partial quotients with remainders. So we're going to continue with our partial quotient method to solve long division, but this time we're going to do some with remainders. So as I look at this, I have 5 as my divisor, and my dividend in here starts with 7,000. So I know that 5 goes into 7,000 1,000 times, because 1,000 times 5 equals 5,000. Now my strategy is usually to try to get that, largest place value out of the way, right? So now I have 2,239. I know that if I look at these front two numbers, 5 times 400 would be 2,000, right? Because 5 times 4 is 20, and then we have 2 zeros here in that 400. So then I can subtract, and I'm left with 239. So I know that there are 20 nickels in a dollar. So 5 times 20 would be 100. So I can get rid of 100. And now I'm left with 139. I can multiply by 20 again. 5 times 20 would be 100. Oh my gosh, I'm running out of room. So then 5 goes into 39. I'm going to move this up just a little bit so we can get in there. So 5 goes into 39 how many times? I know that 5 times 7 is 35. And when I subtract, I get 4. So the question then becomes, can 5 go into 4? Because if it can't, then that's a leftover, right? Or a remainder. So what we're going to do, so 4 is going to be our remainder. So we're going to add up all of these numbers that we've divided. So I get 7, 4, 4, 1. 1,447. Remainder 4. So our answer is 1,447, remainder 4. All right, let's try another one. So for this one, 4,543 divided by 3. So again, I look at this thousands place and see if I can start kind of whittling down this number. So can 3 go into 4,000? Yeah, 3 times 1,000 is going to be 3,000. So now I'm ready to subtract. So I'm down to 1,543. If I look at these front two numbers here, I know that 3 times 500 is going to be 1,500, because 5 times 3 is 15, and there are 2 zeros there. Then I get 43. So let's see, 3 times 10 would be 30. Subtract, and I get 13. So 3 goes into 13 4 times. 4 times 3 is 12. I'm going to subtract and get 1. 3 can't go into 1, so that's going to be our remainder. So 4, 1, 5, 1. 1,514, remainder 1. Does that make sense? So we have R1 there at the end. So remainder 1. Okay, let's try another one. 7,965 divided by 2. So again, I'm going to look at that thousands place. So how many times can 2 go into 7,000? It's actually going to be pretty big this time. 3,000 times. 2 times 3,000 is 6,000. And then we have 1,965. Again, I'm going to look at those front two numbers. 2 goes into 19 6 times, right? Or not 6 times, more than that. 9 times. I can go in 9 times. So 2 times 9 would be 18, right? So we have 9, and then we have 100. So 2 times 900 would be 1,800. If we subtract, we get 165. And then let's see, we've got an even number there. 2 goes into 16 8 times, but that's like 160, so it's going to be 80 times. So 2 times 80 would be 160. We'd have 5 left over. 2 goes into 5 2 times. 2 times 2 is 4. Subtract and we get 1. So 1's going to be our remainder because 1 is less than our divisor up here. So we're going to add this up. 2, 8, 9, 3. So 3,982. Remainder 1. So that is our answer. All right, let's try another one. So 6 can't go. This is going to be smaller than 6,000, which has been our kind of our go-to for our thousands place. So we may need to look at these front 2 numbers. So how many times, if we estimate, how many times can 6 go into 53? So 6 times 9 is 54. So let's try 6 times 8. 6 times 8 would be 48. And we would have these 2 place values over here. So 6 times 800. So 6 times 8 is 48. And then we put 2 zeros here. Okay. Ooh, that's a really crooked line. Let's make it straighter. There we go. So we're going to subtract 9, 4. Oh, we have to regroup. 13, that's a 4. 13 minus 8 is 5. 4 minus 4 is 0. So now we are looking again at these front 2 numbers. 6 goes into 54 9 times. And it's going to be in the, we're going to have an extra 0 at the end there because this is actually 540 instead of just 54. So now 90 times 6 is 54 with a 0 on the end, so 540, goodness. And then we're left with 9. So 6 goes into 9 1 time. 1 times 6 is 6. Subtract and we get 3. So our remainder is going to be 3. Your remainder has to be smaller than this divisor out here. And that's one way that you can check. If this number down here is bigger, then you know that it can go in more. So we're going to add these up. 1, 9, and 8 with a remainder of 3. All right, one more problem. So 8,348 divided by 7. So we're back to our thousands where we can fit this 7 into there. So 7 times 1,000 would be 7,000. And you don't have to underline these numbers. This is just sort of me trying to show you what I'm doing in my head and what I'm emphasizing in my estimation. Okay, so we subtract this and get 1,348. So, if we look at these front 2 numbers, 7 times 2 is 14, so that's not quite going to be enough there. So 7 times, we could do 100, which would give us 700, 100 times 7. Then we can subtract, and we'd have 648. So next, let's see. Let's look at this 64. 7 times 9 is 63. So let's see if we did 90. Oops, I need my pencil. 90. 9 times 7 is 63. And our 0 there. So then subtract. We get 18. So now, how many times can 7 go into 18? 7 times 2 is 14. And we'd have 4 left. And since 4 is less than 7, that's fine to be our remainder. So now we're going to add up our partial quotients over here. So 2, 9, 1, 1,192 with a remainder of 4. All right, so that is partial quotients with remainders.